Completing squares concept. I'm Anil Kumar. I'm trying my best to explain this concept to you, and I hope this video helps you to understand a bit of it. Please feel free to share your comments and suggestions so that my method can be improved. The question here is, find the area of the small red square which would be added to complete the square. Then write an expression to represent the area of large square in two different ways, binomial square and standard form. I know all that makes sense, but sometimes it becomes difficult to understand. Well, these are my different squares, and these are my small red squares for which you need to write the area. But what am I trying to say? Let's go through the question once again and then figure it out. Okay, it says that find the area of small red square, that means this one, which would be added to complete the square. So think as if the square is not there, so it is added to complete the big square. Well, let's look at it in another way. Let me draw this square here. So I left this space for kind of explanation. I thought that would be interesting. So this is my square whose area is x square. Area is x square since sides of my square are x and x. Now on top of this square we have a rectangle. Okay, so we have a rectangle. We have a rectangle on the side also, right, like this. So that is these two rectangles. And what I'm saying is, let the width of the rectangle be a in both the cases. So this is a, right? So I have this rectangle on top of the square whose area is how much? Well, it should be a times x, right? So it should be a times x. So let me write down the area a times x for these rectangles. A is the width and x is the length, right? So that gives me a times x. So I kind of get one figure which is not kind of square, right? But if I add a red square, so this is the red square which I want to add, right? If I add this red square, then it becomes a complete big square. Okay? Now the question is, find the area of small red square, this one, which would be added to complete the square. I hope now it is complete, right? So this is what we call completing the square. So we didn't have a square, we added one red square to complete it, and that's the method of completing squares. Now let's look into the second part, which says, then write an expression to represent area of large square in two different ways, binomial square and standard form. Okay, two different ways. Okay, let's explore that part also. Now, area of this square is how much? Big square. This side is x plus a, perfect. And this side is also x plus a, correct. So, area of big square is clearly x plus a whole square. So we can write area as equals to x plus a whole square. Well, that is this binomial, and then square. This is what I mean, right? So I hope you understand what I'm trying to say, right? Okay, so this area of big square is x plus a whole square, and we have to write it in two different ways. The other way is standard form. Okay, well, standard form is kind of three terms, right? How do we get that? Let's look into it once again. Okay, so we have this big square. Area of this big square will be a equals to, let me add all these. Okay, this is x square plus ax, and ax means 2ax, plus area of this square, right? Plus area of this square gives me the total area, and that is the standard form. Correct. That is the real question. Okay, so let's get back to the question once again and answer it. It says, find the area of small red square, this one, which would be added to complete the square. So we add this to complete the square, right? Now what is the area of this small square? Well, it should be A times A. Well, the dimensions are A and A. If I multiply, I get A square. That's what it is. So I could write this as, let me write now here clearly, area should be equal to x square plus 2ax plus a square. Got it. So that is the general form, and that is your quadratic form in standard form, right? Quadratic equation in standard form, and this is binomial square. I hope now the question is absolutely clear. So to practice, we have three different questions for you. Here I have given dimensions of the square. Here I have given area of square and rectangles, right? So given area. So this case we are given area, right? And in this case we are given dimensions, right? Dimensions. And you need to answer the question. I hope it's absolutely clear. First part is, what is the area of this red square, which imagine is not there, but we want to fit it in so that we form a big square. Once you fit it in, then you have to write the solution in two different forms. One we are calling binomial square, the other one standard form. Okay, I hope that makes sense, right? So let me help you answering these questions one by one, but what you can do is pause the video, answer, and then look into my suggestion. Perfect. So area of this small square in the first case is simple. Side is 3 and this is 3. So, well, this area should be 3 times 3, right? Which is 9. 3 square. Or you could say 3 square. That is what I meant by a square. You get the idea. And the area of big square is dimensions x plus 3. So I could write this as x plus 3 whole square. Perfect. And the standard form, area of this square will be x square. Area of this square will be 3 times x. Well, 3 and x, right? 3 times x. And this one we found 9. So total area will be, let me write this time with a, equals to x square plus 3 and 3, 6x plus 9. That's it. Correct. So that is how you have to solve these questions. Let me do one more, the last one for you. Here, the area of the square should be square of these x's, right? So this is x, 1 and 1, correct? Since the area is x here, x square means x and x is the dimension. Area is x means these sides are of length 1. Okay, so in that case, this area is 1 square. So this area is 1 times 1. Let me write 1 square, which is 1. So this is the area of our red square. Perfect. And the area of the big square is x plus 1 whole square, or I could write this as combination of area of these squares and rectangles. So 2x plus 1. That's it. So that is how you can understand and solve such questions. I hope that makes it interesting. And this one, finally, I'll leave it for you, right? So you can write down the area of this small square, area of the big square in two different forms. I hope that helps. Thank you and all the best.